All right, thanks a lot, Dave. So this talk is going to be about DVswitch and how we're going to try to use that to link our DMR system over to the analog Qualcomm system. This is going to be to support a regular net that takes place on both of those systems, and we want to expand the um, coverage so people can join in on both of these systems. All right. But before I talk about that, I think Doug just kind of alluded to this. The reason why I am doing this remotely is because I am kind of jet lagged coming back from a trip to Japan. I got back not too long ago. It was a 30-hour travel door to door. But I just wanted to share some cool stuff from there. I had a chance to go to all the electronic and radio shops that they have there in the Akihabara neighborhood of Tokyo. So they have many buildings worth of electronics component sellers there. Basically everything if you want, wires off the rack, amateur radios. There's a big icon billboard hanging there, so that's kind of a good clue that you found the right part of town if you're a ham. Lots of really fun stuff to browse through. You may also be wondering, did I actually operate in Japan? Unfortunately, the answer is no. There is some reciprocal licensing agreement with the United States, but unfortunately, you actually have to go and apply for a Japanese license. You can't just show up there and turn your radio on like you can like the CEPT countries. And that did require you to actually have like an address to receive that license locally. You had to basically provide the Japanese equivalent of your FCC ID for the radios you plan to operate. Those are kind of just too many hoops to jump through, and I had a really packed schedule anyway, so I did not do that this time around. But maybe in the future, that would be a fun thing to do. All right, so repeater network linking. I'm sure most of you are familiar with these two, but here at Rocky Mountain Ham Radio, we operate a regional DMR network. It's all based on Motorola/Moto Turbo DMR equipment. So these repeaters natively support IP linking using a protocol called IP Site Connect. Using this, you can basically group up to 15 repeaters together, and they'll basically pass audio between them. They basically form a connected graph. But if you need to have more than 15, there are other components you can add, such as a C-bridge, which is a piece of software that runs on a server up in Thornton Mountain that is able to basically link multiple of these IPSC networks together to create even larger groups of repeaters. And that's basically the basis of the Rocky Mountain Ham DMR system. Most of that is backhauled over private microwave links with some VPN tunnels over the public internet as well. Another very wide-reaching system that many of our members are involved in as well, and certainly use regularly, is the Colorado Connection. This is a 2-meter analog FM repeater system that's also linked statewide. And that linking is happening using Allstar link. So that audio is digitized at each site, and there are voice over IP asterisk links connecting that all together. Willem is going to be talking about that in a lot more detail in the next talk. I should say mostly digitally linked. I believe there is one site out there that actually has a traditional RF link. I think it might be the Eagle Vale site. Doug or Willem can correct me on that. Yes, okay. The Qualcomm system is also being backhauled over RMHAM's network. We try to cooperate pretty heavily and share resources in that regard. But one thing that does mean is that all the data is kind of in the same place, right? Qualcomm audio, DMR audio, it's all flowing across the same links already. And one thing we'd like to be able to do, or at least have the option to do, is to be able to link these two systems together to cover nets and events or emergency situations, whatever might come up, and have that capability. So obviously, the DMR is a digital encoded audio stream, right? It's using the AMBE codec. The analog Colcon connection is digitized as just standard PCM audio, totally unencoded, very easy to work with. If we're going to bridge these two systems, obviously we have to do some conversion here. And it turns out there is a collection of software called DVswitch that has been designed by hams to basically try to link as many of these digital voice modes together as possible. And that includes everything from IPSC, like what we're using in the DMR network, to Allstar link asterisk connections, to interfacing with all the hotspots, like with the NM0TH software. So it is really flexible, but it's also not a singular tool. You basically get a collection of different pieces that you can chain together, kind of like how you are not supposed to use electrical adapters. It's unfortunately not very well documented, and not all parts of it are open source. But if you're willing to sit down and play with it and read as much as you can on their website, you can get it to work. If all goes well, there will be a little demo at the end. I can show you the current status of how this is going. There's some links below that you can follow. Get the slides afterwards or rewind and pause here. But those are your starting points for the different things that you're going to need. So speaking of that, I mentioned that we have to glue together a couple different pieces. This is the chain that we need to do what we want. So going from left to right, we have that IPSC network. In this case, I just threw a couple of DMR repeaters into a network there. In IPSC, every node connects to every other node to share audio. So there's 3 repeaters there, inter-networked. And then we have this piece of software from DV-Link called IPSC Bridge. All right, this is the part of the system that joins into that IPSC network. It functions just like another node. You could imagine that being like a 4th repeater, except it's not a repeater. There's no radio attached there. It's just joining into the network and able to pick off audio streams and also inject streams from the other end back into that IPSC network so that flows out to all of the repeaters. Now, the IPSC network is more complicated and not as easy to interface with. So the role of IPSC Bridge is to kind of handle the IPSC protocol part and then just expose a UDP socket endpoint to transfer the extracted A and B audio back and forth. And so important to note, at this point, it's still A and B audio. We just took it out of the IPSC protocol wrapper. The next point in the link is where we actually do the analog digital conversion and the vocoding. Well, I shouldn't say analog digital conversion because it's all digital at this point, but that's where we turn A and B audio into PCM and vice versa. After that, moving on to the right, we're running a local asterisk Allstar link node. And Analog Bridge is able to interface directly with that Allstar link node through something called CHAN USRP. I'll talk more about that in a little bit. And once you have audio inside asterisk, you can now just use normal Allstar link linking procedures to now connect that node to whatever else you want. So in my test environment, I am using a CRA repeater on El Dorado Mountain, something that Dave has set up for me to test against because it's usually not linked to anything else. So we'll be targeting that repeater and basically creating an Allstar link connection from my local node that's hooked up to the DVswitch programs out to El Dorado Mountain. All right, so a question from Chris. If the analog bridge is doing the A and B to PCM transcoding, does it need one of those dongles with an A and B chip? It's a great question, and we're going to talk about that on the next slide, actually. But covering IPSC bridge real quick, I think I already mentioned most of these points. It joins into the IPSC network as a peer. It's capable of running as either the master or just as a peer. In our RMHAM network, we tend to choose a particular repeater to act as the master, and the C bridge and other repeaters act as peers. So In that case, you would probably have IPSC bridge act as a peer as well. It's also possible just to have a point-to-point IPSC network. So you could have the C bridge on one end and IPSC bridge on the other, and have just those two things on the network to basically create a point-to-point connection. And that's probably what we'll end up doing in the real system, just to keep this separated a little bit from the real repeaters. This gets a little bit confusing to keep track of. There are multiple UDP connections going on between all of these programs. And so in IPSC bridge's case, it's sending packets out on UDP 31003, and then listening for incoming AMBE packets on 31000. And that's what goes sent back out over IPSC. Very easy to get those reversed and have situations where you have two ports kind of pointing at each other. So just read all the configurations very carefully. All right, analog bridge. So this is kind of like the glue layer. This is where we do the actual vocoding AMBE PCM conversion. So out of the box, it is capable of running a software vocoder. It's basically one of those reverse engineered open source AMBE or IMBE implementations. Not the greatest quality. If you want to have much better conversion quality, it is capable of working with a hardware vocoder dongle. And this is what I think Chris was alluding to. So if you want to see what those look like, looks like a little USB thumb drive. This is a DVSI. That's the inventor of the AMBE codec and the rights holder. They sell DSP chips that have the vocoding algorithm burned onto them. And what this company, Northwest Digital Radio, has done is they took one of those chips, combined it with a USB UART serial port bridge, and put it into this nice little package that you can plug into your computer. And basically, you're going to see a serial port or COM port show up that you can basically direct PCM or AMBE packets to, and they'll do the conversion for you. So you can buy these. I think there's a couple other vendors out there. They're not cheap, unfortunately, but here at RMHAM, we have a couple of these that we use for experimentation. So I was able to try these out. And the conversion quality is as good as it's going to get. This is literally the reference implementation that you're working with here. And much, much better than the built-in one. But going back real quick, AMBE bridge is very flexible. So we're using it here to basically interface from one of the bridge devices to asterisk. But you can also sort of bodge analog bridge together back to back if you want to do conversions between two different digital protocols. You kind of use analog as an intermediate conversion step and then go back out over something else. I would recommend you page through the DVswitch forum and wiki and just see all the different things that it can interact with, because it's quite a lot. Unfortunately, it's not always the best documentation, and it's all like network based, right? So as far as I'm aware, it doesn't have any way to directly interface to like a physical radio or SDR. You just need some kind of adapter program in between to do that part. All right, so moving on to the final piece of our chain. This is the local asterisk node. And so the way we interface with this asterisk node is that we are using an asterisk feature called CHAN USRP. Basically, this is a simple UDP audio passing protocol. Analog bridge is able just to send PCM packets off into a port that asterisk is listening on, and vice versa. Asterisk can send its inbound audio back to analog bridge over a different UDP port. You might be wondering, why don't we just do CHAN URSP connections directly to the remote Allstar link node? I assume you probably could, but I don't think this is really optimized for like internet connections with jitter buffers or anything like that. It's meant to be used locally. By having this local node, I basically get to have a node number that's assigned to my setup, and I get all the normal asterisk linking controls where I can tell my node, all right, go out and connect to that node. Um, I can control the telemetry tones to my liking, whatever I want. So normally, yeah, an asterisk or an Allstar link node would have something like USB radio or simple USB type devices attached where there's a physical radio associated. In my case, no physical radio. This node is getting its audio over CHAN USRP, and that also includes the signaling information like when PTT is on and off. Got a comment here from Nate. DVswitch mailing list is also information dense, but also lots of newbies and very high traffic. Highly recommend sending it to a folder if anyone subscribes for detailed sorting and reading later. High traffic is an understatement. Yeah, the link I showed a couple slides back will also get you to the mailing list. You can read it online or subscribe if you're interested in this project. Honestly, the mailing list archive seems to be the most useful place to get up-to-date information on this project. Like I mentioned, the documentation is really not that great, but chances are you can find somebody else that's been having the same problem as you or wants the same kind of setup as you if you search through their mailing list archives online. All right. So the way that I've been testing this stuff at home is I'm fortunate enough to have a couple of repeaters that are racked up in my basement here for testing purposes. So on the top there is a UHF XPR 8300, and then below that is a VHF 8400 that's on loan from RM Ham. These are just connected to dummy loads. I don't need any kind of real coverage here. As long as I can interact with these repeaters from 50 feet away where my desk is, that's good enough. So these are running on what CCARC calls shared non-protected repeater pairs. So these are a couple of frequencies in each band that are uncoordinated and free to use for any amateur. They work really great for temporary deployments or testing. And another comment here that the DVswitch developers are also active on the mailing list. Yeah, so you can get help from people that wrote it if you need it. Going back to the repeaters, yeah, uncoordinated on a couple of pairs that allow for that. Very useful for testing purposes like this. Although where these are located, I don't think they're going to get out much beyond the city block here. So both of these are in network. I have a little test network right here, and I can connect to these over IPSC. And slightly above this is a Dell server that is in my house that I run a bunch of VMs on for various purposes. And we're going to connect to that shortly here because I have all the programs that we talked about previously running on that machine. You'll get to see them all live, and we'll try to make some calls. And you can see all the different pieces working. So I am going to go ahead and switch over here real quick. All right. Let me get all my radios connected here. All right, so this is
Call yourself a nerd,
VHF.
but you only have 4 screens up. A real nerd will
Well,
have at least 10 screens up.
I've simplified things a little bit here. So top left is an asterisk console. Top right is IPSC bridge. And then, excuse me, bottom right is analog bridge. Bottom left is Vim that has one of the config files open. I think that's yeah, that's asterisks rpt.conf. I was playing with this earlier. Hopefully it's all still working. But yeah, I've got a VHF DMR radio right here. This is just connecting to that test repeater you saw in the other image. So if I key this up, NM0TH, you can probably hear the DMR jackhammer buzzing being picked up in the mic cable. But as you saw some activity there in the background. Okay, that's something you probably don't hear very often on a DMR machine. That was the repeater identification. That was actually coming from Allstar Link. I have the telemetry tones turned on just for testing purposes, and that was basically emitting my call sign from asterisk through analog bridge out over the IPSC network and out the repeater and being received here on this portable. So yeah, that kind of demonstrates the whole chain working. But if we want to take this a little step further, I do have another radio right here. This is connected to the CRA Eldorado repeater, which I can kind of receive in my basement. It'll be a little bit scratchy, but you'll be able to follow along. So in the asterisk console right here, I'm just going to issue the linking command. So I'm going to tell it, take my node, which is 1000, connect it to 1316, which is the node number for the CRA Eldorado machine. That's only accessible on the RMHAM network, so this isn't like a public Allstar node. But that's not actually important right now. So issue that command. We should hear Eldorado announce shortly if the connection went through or not. Yeah, I'm not sure if you heard that. I had to hold the radio up a little bit higher, but you probably heard the tail end of the Allstar link announcement on the Eldorado end saying that we had linked. But basically now, if I go ahead and key this up, NM0TH, testing DMR linking, you can kind of see that some activity has happened here on the console again. It's probably going to be pretty hard to demonstrate. But that was me keying it back up the other direction. You kind of heard the squelch tail there. NM0TH test. Test 1, 2, 3. Yeah, sorry, that doesn't sound very impressive at all. It's kind of hard to test when you have the two radios right next to each other. There's going to be a lot of feedback, and also this still needs further adjustment to get the levels correct. And I'm not really in a great spot to receive the Eldorado repeater. But hopefully that's just at least enough of a demo so you can see all the different parts moving. Yeah, so do we have any other questions here? Looking at Zoom, I see a comment from Chris. That's very cool. I know you've also experimented in the past with DMR data. I assume that gets filtered out from DVswitch, or does it cause data noise in the ASL? That will get ignored by IPSC bridge. So data is a different type of call that comes through IPSC. IPSC bridge is only looking at group voice. Those are the things that are going to a talk group as opposed to any kind of data or any kind of private call. NM0TH test. Test 1, 2, 3. Test 1, 2, 3. NM0TH test. Test 1, 2, 3. Test. I'm not sure you can kind of hear the echo going on there. You can hear my voice coming out of the Eldorado radio shortly after I say it.
I can see you lighting up the Common receiver. So
oh, perfect. Yeah, Willem's going to share a little more about that next.
And I'm logged into that node up there using IEX RPT, and I can hear you coming through clearly.
Okay,
from
that's awesome.
From DMR. Your VHF isn't making it at all.
Sorry, from DMR or from the analog UHF?
I'm hearing DMR okay.
Okay.
But I'm pretty sure the analog VHF or UHF isn't getting there.
Yeah, I'm not surprised. When I was testing with this earlier, I actually just set up a mobile down here in the basement and ran an antenna up to the living room to make it a little bit easier to debug. But good to know that the DMR is coming through. That's like the main thing that we're trying to test here. NM0TH. Oh, this radio was turned off already. This one, NM0TH testing DMR. Sorry, I have 2 VHF portables on my desk right now. All right, any other questions? All right, well, thank you very much.
Sort of something
Back
that's
to you, Willem.
This
go
has
ahead.
been something that's been long in the making, so glad that it's finally working.